I studied computer science in the 90s, and I suspect curriculum in most universities has not changed significantly. You're really at the forefront of what's happening in the AI space with your work at Atlassian. As a technologist, what do you think about this paradigm shift? Software fundamentally wasn't changing. There was a more and more layer of abstraction, so you can do more with less.
It's a new world. The stuff that we learned in the 90s, many of those things are not being needed for around 10 years. The pace of innovation is far outstripping the pace at which education is actually changing. Well, with AI, one of the key problems that hasn't been solved is how does an AI show empathy? The thing that I'm very bullish about is a humanoid robot. This concept of theory of mind is not yet built into LLMs today, and it's a hard problem to solve.
Shamik, welcome to SparX.
Thank you.
Yeah, I think you and I have worked together for what now last 13, 14 years, except last 1 year. And good to see you're wearing cult sports shoes. So still loyal to the brand. That's one of the many things we did together. And you will probably happy to hear that cult sports is doing incredibly well now.
Yeah.
I think finally, last year or so it started to hit stride. And I think feeling pretty bullish about where it is going. But you have been in the technology space, Shamik, for last, nearly 30 years now.
Yeah.
You did your startups in Valley, and then you were among the first few people who started coming back to India in that 2010, 11, 12 timeframe. We did, I think, a bunch of really interesting stuff at Myntra together, then later on at Cult, and now you're really at the forefront of what's happening in the AI space with your work at Atlassian. But one of the things, as I was thinking about this episode, Shamik, I realized that while a lot of technological breakthroughs have happened over the last, 30 plus years, there have been paradigm shift and so on, but software was at the obviously at the heart of everything that was being developed, and in some ways software fundamentally wasn't changing. There was a more and more layer of abstraction, so you can do more with less. But suddenly we find ourselves in a time where what software means itself is changing, with this whole advent of vibe coding and English as a possible programming language and so on. So as a technologist, what do you think about this particular paradigm shift when it comes to building, creating new technology? Seems very different than anything we were familiar with.
Yeah, I think that's absolutely right that this is it's a new world, and what we mean by software itself is changing. I think as we discuss in our conversation, right, we'll see that probably we have to kind of think of a higher level of abstraction that, previously software used to think about, okay, here's a CPU, here's memory, and here's a file system and other constructs like that to be able to work with. Now you're mostly doing prompt-based vibe coding and other kinds of higher level of abstractions. But I suspect that we will find that there is another layer on top. And on top of that, the fundamental concepts will still be there about how do I construct software. It is just that the programming language will change. And even though today we're using English, I suspect a more structured form of English will emerge. That will be the new AI programming language, right? And this, new forms of the current constructs.
English will be the AI programming language, or Hindi?
No, I think it'll be English only, but it'll be a constrained form of English. So, for example, if I'm describing how to build an app, I will be describing it in English, but I'll be putting, okay, here are the constraints, here are what it should do, here are the things you can access, here are the, privileges and permissions you will need, who can access it, what should you do in case of failure. So when you start writing it like that, it almost seems like, yes, it's English, I can understand it, but it's also a new kind of programming language.
As you're saying it, I'm realizing when I work with people, and sometimes you have to explain things to people. And sometimes I realize that, if I break things down, that this is my intent, these are the past learnings we want to use. If I'm structured in my communication, the other person gets it and the quality is good. But sometimes you come across someone who is more organized, more intelligent, and you just describe it at a high level, you hand wave, the person still gets it and still gets the job done. So won't AI eventually get to that point where you don't need to be so organized and structured, and just literally explain the vibe of what you're trying to get done?
Yeah, I mean, I think at the end of the day, even if you're talking to somebody who has a lot of agency and is able to do things on their own, in order to get an output that you are expecting and that you're happy with, you will at least need to have a conversation, right? And at the end of the conversation, whether it is you who gave the structured specification or whether the person who received your vibe and then was able to come up with the answer, they will need to create a structured specification. But I think the structured specification is important. And we call that in software engineering, whether it's a detailed PRD, right? Or, you can tell a vibe to a product manager today and they create a PRD, right? And you're like, wow, that's a great product manager. But the PRD needs to exist for the product to, work and be built in the right way and to be maintained and so on. So yes, I think an AI can create a PRD for you, but it'll need to have a conversation for you to gather the intent and then create that very detailed, structured PRD.
So we can break it down. Maybe we'll come back to this. But let's go back to the kind of foundations of software engineering. You studied computer science. I studied computer science in the 90s. And I suspect computer science curriculum in most universities has not changed significantly. Maybe there is a course on machine learning now. But how useful is learning about traditional computer science? Same courses on computer architecture and databases and compilers and algorithms. Does anyone need to study those anymore?
Yeah, I mean, I think the stuff that we learned in the 90s, frankly, I think that many of those things are not being needed for around 10 years now, right? So I used to learn assembly language, for example. I don't think anyone learns assembly language. And I used to, we had a course where you actually had to build a computer from scratch, including the chips and the ALU and all of that, right? That has not been the case for a long time because we have built higher levels of abstraction and then we can model the computer in a certain way and then programming languages take all that complexity away from you. I suspect that, the computer science curriculum has to change to come to even higher levels of abstraction, right? When all of this gets abstracted away, what remains is the question that we should ask, right? And there are certain things that I think will always remain. Like, what is the interface that I want from between humans and agents to agents? So API design and interface design, I think, will always remain an important area. Same thing with memory. I think memory and who knows what is not just a computer science thing, it's a sociological thing, right? And we can get into the theory of mind, but I think that same concept is applied here. We just need to model about this agent or this AI is allowed to know X. This other thing is allowed to know Y. And then if I know X and you know Y, then how can we collaborate, right? This is what happens in humans, right? The reason we are having this conversation is because, you know X and I know Y, and we want to kind of figure out what we can, create in this conversation. And same thing happens, I think, with AI, irrespective of how knowledgeable it gets. So being able to design with these constraints, I think, is a software engineering concept that I think will still be important for people to learn.
Jesse, I'm asking this follow-up question on the behalf of someone who is 18 or 20-year-old, just entered college. You went to IIT Kharagpur, I went to IIT Kanpur. These days, all the top 100 rankers go to IIT Bombay. So you're just joining IIT Bombay. You got a great rank. You have got computer science. What should you study? And I don't think IIT Bombay is changing their courses fast enough. I suspect 90% is probably very similar to what we studied. So seems like a huge mismatch.
Yeah, there is a huge mismatch because I think that the pace of innovation is far outstripping the pace at which education and curriculum pedagogy is actually changing, right? But I think people can self-learn. And I think most smart people today, they learn the fundamentals from whatever the teachers and universities are teaching. But in order for you to be abreast of what's happening in this world, I think a lot of self-learning is needed. And the good thing is that a lot of self-learning mechanisms are available today, whether it's YouTube or something else. So the areas that they should learn, I think, is a more interesting question, right? I think obviously they should learn about the fundamentals of mathematics, statistics, and so on, because I think that will still remain. And if I look at new fields that people should learn about, they should learn about probabilistic reasoning and so on. But I think another interesting area they should learn about is sociology, right? Because previously we used to use math and computer science and all of that to model the hard sciences.
Mhm.
And what is now changing is that the soft sciences are getting modelable, right? And if you can combine what AI can do with all the softer sciences, and the reason I say either psychology or sociology is because what I think will remain is how people work together. And that I think is not solved.
Yeah, I think your current comment is reminding me of something, very interesting, which happened in my first year in college. I don't know, I was very prescient maybe at the time, but I didn't take a sociology course in my first semester, or I don't know why. But that teacher was very particular and wanted a lot of class participation in English. And I was from Haridwar, first semester in college. I couldn't speak English to save my life. So I did not participate and got a C in that course. And all my, aspiration of maintaining a 10 point and all that, went for a toss. So sometime taking sociology can go wrong. But I agree with you. I think overall emphasis on humanities.
Yes. Yeah.
Probably, do you think, out of these colleges should consider a quarter of their courses in humanities now?
Yes, I absolutely would vouch for that, right? I think the new innovations will have to be in terms of how do people work together? How do you operate in silos of knowledge? And how do you model how people think? Because these are all unsolved problems. Like, for example, with AI, one of the key problems that hasn't been solved is how do you give the right personality to AI, right? How does a AI show empathy, right? This is a psychology and a sociology problem, right? And you have to be able to compare that up. And how do you model that inside a model, whether it's a language model or a world model or any kind of AI? If we have humanoid robots and so on, these becomes extremely important problems to solve.
And within companies, in the past and all the work that Shamik, we have done together, we always had kind of two struggles around software engineering. One was there were never enough software engineers. We always wanted more, but there are budget constraints, talent constraints, how many you can hire and so on. And second is as the number of the size of engineering team keeps growing, productivity keeps going inversely proportional. At some point, you think you are doing almost the amount of work with 500 engineers that you are doing 100 engineers. With, again, AI becoming so integral to how software engineering is done, does that dynamic change? Can people start to think I can now operate as if I have 1,000 engineers, 10,000 engineers? I have no upper limit to how many engineers. And perhaps the collaboration, maybe is somewhat linked to what you're saying about sociology, but maybe that inefficiency can be also removed considerably.
It's a point that's, I think, up for debate, right? I have a point of view, but I'm not fully convinced that is the right answer, right? There is one angle that is clearly that as software development gets easier to do, and it's not just vibe coding, even like just tab completion, even if I'm doing like, very small tasks inside, improve my code, AI makes it a lot faster, right? So engineers should become much more productive, right? And the amount of code that is generated should increase. I think that everyone is aligned with. Do we need more software engineers in an org or not? It's an open question, right? One line of thought is that in the past, as coding has become easier, you went from assembly language to programming language, it became easier, programming languages to more and more libraries and open source, it became easier. But the number of engineers never reduced. It's just that the amount of code that was needed was expanded so much, right? That is one line of thought, right? So that even with AI, we'll just write so much more code that the number of engineers will not necessarily have to decrease. The other line of thought is that, if the whole field can be automated, then you really don't need as many engineers. But you may need enough number of coders still. It could be that all the marketers, all the finance people are all writing their own little apps, right? And then they're not really engineers and programmers in the developer sense, but the total population of people who are using these programming tools and are doing some form of programming is still very high. I think both of these things are possible. I suspect my own point of view will be somewhere in the middle. The number of computer science engineers we need is probably going to be less, but the total number of programmers we will have in this world will probably be more, or maybe not increasing at the same amount of code, but it will be still overall.
So in some ways, if the natural language itself become kind of programming language. Maybe it is structured, and effectively anyone has some job to be done.
Yes.
Can operate like a programmer.
Yes.
Leveraging natural language. Do you use any of this AI-enabled IDEs like Cursor, Windsurf?
Yeah, I use Cursor, and I use it often. Something like Replit for deploying code and so on. I don't usually use all the CI/CD tools and all the other tools that are also out there.
So maybe a lot of our listeners are going to be people who are not programmers. Can you just take a few minutes and describe, what does Cursor do? What does this AI-enabled programming looks like? Just to paint the picture for them, so people can visualize why AI in software generation is a big deal.
Yeah, sure. Perhaps it helps to step back a little and say what a software development life cycle is. Like, what does a day in a software programmer look like, right? And people often associate with coding because that's kind of the artifact that people see. But typically, a software engineer starts their work and ends their work in a much bigger spectrum of things. So typically, things start off with a requirements document, like what do you want to build, and they interface with other people in the org to figure out, okay, we should build X. And they write it into what is known as a requirements document, often known as a product requirements document called a PRD. And then several days, maybe weeks are spent in actually crafting the PRD, saying, this is how I think we should be going to build it.
Did I ever tell you, sir, before Myntra, I worked as a product manager for 5-6 years. So I've written a lot of PRDs in my life.
So I think all of us in the technology field are very familiar with this document called the PRD. And for those people who are not familiar with the software engineering document, and if you've been in any house building project, it's like creating the design of the house. You have to do that even before you start building the house, right? So a lot of time is spent in creating the PRD. And then after that, you have to create what is known as the software architecture diagram. And that defines a little bit about, like, if you're building a house, then what materials am I going to use? Where are the electrical points? And all of the details of how the house is going to come together. And then after that, the coding starts, right? And then the coding can take several weeks, months, sometimes years as well, depending on how big the project is. And then after you build it, there is you have to actually put it onto the servers, and you have to test it that it's actually working. So there's a whole bunch of activities that come there. And then after it is running, then you have to operate it and make sure that there are no problems in the thing, because customers might come and face some problems. So there's always these operational issues that come up. So this is the entire life cycle of a software engineer, and they spend a lot of time in each of these activities. A lot of the innovation and the news that you hear today is about the programming and the coding part of it. And there are tools like Cursor, Windsurf, and others have actually come in and have automated a lot of that away. So you can just tell it, like, here's the requirements I have, and then it just creates a lot of code. Sometimes the code matches what you want. Sometimes it's too verbose. Sometimes it goes off and does something that you didn't expect it to do. What
is the quantum of code it can generate? Is just code completion for whatever you're doing immediately, or you can generate many files simultaneously, hundreds or thousands of lines of code?
Yeah. So let's take an example, right? For example, something like Cult Sport, right? Which we built together, the website for that. Ballpark, I would say that's probably 100,000 lines of code, right? So let's take example. Let's say it's about 1,000 files in your file system, and each of those files is about 100 lines of code, right? So 100,000 files, about 40, 50 engineers working for a year would have created that much, right? I'm giving very swag numbers. So it's almost like, for people who are not familiar with programming, if I have to create 100 documents each with 1,000 documents each with 100 lines, right? That is the amount of code that has to get created. Now, if you tell an AI system that I want to just create cultsport.com, it can actually do that, right? Especially if you say, point it to another website saying, here is what you should look like, create something like that. It can take a few 30 minutes, 1 hour, and it can actually go and create it. But because there is so much variability and there's 1,000 files, each of them have 100 lines, many of the things won't work, and things will, even if it does work, it may not work in the way that you wanted it. So that's known as vibe coding, right? So you just give it, I have a vibe that this is what it should look like, go off and do it. And then you're stuck with the problem that, wow, I got this big morass of stuff and it doesn't quite work the way I wanted it to. And now fixing that is a big problem, right? So vibe coding in this kind of a model usually works for very small things. I want to create a little internal app that helps me, just me, manage my to-do list, right? Then, yeah, it might create something which is not exactly the way you want, but it's fine. But if I wanted to create a public cultsport.com like website, that is probably not the right thing for vibe coding. So most in enterprise production environments, you take a much more limited approach. You put the structure, you say, okay, here are my folders, here are my files, and then you give one of those areas to each engineer. And then each of the engineers say, okay, these are the functions I will need. And now AI, can you actually just create this file for me, given that this is what I want to do?
And these things are continuously getting better. So based on where we are today, what is your estimate of what kind of productivity boost, if anything, an average software engineer is able to see?
So in the coding part of the life cycle, right, I think the productivity gains are already very high.
But coding is 20% of software engineer lifetime?
Yeah, I would say probably about 10 to 20%.
That's it. Other 80-90% is requirement to administrative stuff.
Yes, and right. And a lot of it, we should not forget, is in the operating it, right? So I would say about 30 plus percentage, maybe 50%, right, goes into just managing the problems that happen in your existing website. So for example, Myntra.com, on the Myntra app, we had, like, when I left, we probably had about 500 engineers. I would say about 150 or 200 of those would be just in making sure it's running fine, right? So there's a lot of that work as well, which we can also talk about. It's not like AI is not touching that, right?
And maybe you explain that also, because one will think, एक बार code लिख दिया, deploy कर दिया, production में तो चल रहा है. Why do 150 engineers need to run it?
Yeah, so there's many nuances to that aspect of it. So one of them is the code that you write is not just the code that you write. It's dependent on a lot of other things, right? You might have got a library from some other party. You might be calling somebody else, like you might be calling JustPay or some other for payment systems and so on. And those things keep on changing. The libraries that you're using, Java changes from Java 3 to Java 4, you have to rewrite or at least go and find out all the things. Security problems keep getting identified and you have to fix it. That's one set of things. The environment changes, hence you have to change, right? The second thing is that scale keeps improving. And as more and more customers come into your website, then you have new problems that you have to solve. And often you have to rewrite a whole piece of the stuff, right? Because the database is not scaling. I need to go from one kind of database to another kind of database. A third kind of problems, the reason that happens is that there are bugs in your thing, which you have not discovered in the past. And then every new day you get a new discovery of something new, right? The customers might say, oh, if I add 50 items to the cart and then I try to apply a discount, then this bug appears, right? So you're constantly fixing those new things that you discover as well. So these are all new things that happen when you're trying to run a system.
Well, and you have point of view on how things evolve from here on, because we are, if anything, very early in the whole AI explosion life cycle. So particularly from software engineering and code development point of view, what kind of breakthroughs one should expect in the coming years?
I think there'll be several, right? First of all, we are focused right now on coding, and there we have made a huge amounts of gains, both in terms of vibe coding, but also more and underappreciated is just in the more smaller file level improvements as well. So I think coding is becoming one of the big gain areas. But if you look across the software life cycle, even in the operations part of it, there are significant gains there. Like, for example, if a problem has happened, then how do I quickly identify where the problem is, right? Fixing the problem actually in something that is already built is actually quite easy, but finding the problem is extremely hard. So AI is actually, being used there as well. Similarly, in the PRD creation, in what should the requirements be, I think there's a lot of innovation still left to do, but visible in the near future about how can I create good requirement stocks, right? So it's almost like you working with the architect and saying, okay, this is my house. If you just give it a vibe thing, I would think I want a great house, right? It's going to create something random. And then you want to be able to narrow it. No, that's not what I meant. This is what I meant. And then to create a much more specific kind of requirement stock. And same thing with the other areas of software engineering as well. I think all of it will get slowly, but I think definitely within the next 2 to 5 years, significantly automated. But one problem will remain, which is how do I coordinate between different things? That is a multi-agent coordination problem that we haven't even, we started discussing as an industry, but we haven't yet solved.
India has a huge IT services export. I think from my understanding is there are, I think 5-6 million engineers who work in with all these IT services giant like TCS, Infosys, Wipro, and so on. And I think most of the work they do is also very maintenance oriented. There is this even humongous systems with Fortune 500, Global 2000 companies. And then they do some customization, some new development, and so on. Are these jobs going to fundamentally change or possibly even go away in 5-7 years?
I don't know about Infosys, TCS, and so on, but I think there's a huge demand for a new kind of services industry. Because the amount of code that exists in the world in these Fortune 500 companies is just ginormous, right? We're not even talking of like hundreds of thousands of lines of code. We're talking like millions and millions of lines of code, right?
Probably I would say even more, hundreds of millions.
Maybe it's like, maybe billions, right?
And some of it in COBOL and
it's like that.
Language is long forgotten.
Yeah. So just making these systems move towards this new world will require a lot of services. So I think there's a big TAM for AI services, right? But it needs a certain kind of talent that I think is currently not yet there in India. Now, India in the past has been very good at its IT edtech, right? Whether you look at Java and suddenly it's slow, but then there's a huge influx of youth that comes in and, okay, we've mastered Java.
Yeah.
I remember at Myntra in the 2013-14, we were struggling to find mobile engineers. And we said, oh, India can't produce more. And then 5 years later, like India has this gigantic number of mobile engineers. Like we are one of the world's best at mobile now. Right? I think the same thing will probably happen for AI. The number of young engineers right now trying to study AI, I don't think it is the same Infosys and same TCS engineers that necessarily will help in this in this change. But I do think India has a big role to play, whether through these existing industries and existing players reinventing themselves or by new ones coming in.
And is this a possibly a new business opportunity also for people to create startups which are focused on leveraging AI to migrate all these legacy codes and re-architect, refactor? Because it's a very, very complex and there's 40-50 years of legacy behind this, very inefficient. Do you consider that as a...
Absolutely. Yeah. I know we've discussed this in the past that I think that, there is a huge opportunity for a new kind of IT services player to come in, which brings just AI expertise at all layers of the stack, right? Right from strategy consulting to IT consulting to actually, migrating the code and maintaining it, right? That whole industry needs to be...
Well, I think as a broad pattern, yes, I agree with you. In fact, some ways, Nurex is also playing somewhere in the stack. But I specifically meant, in some ways, as you mentioned, code completion is the easiest thing to do. Building, toy apps is the easy thing. Well, some more complex thing. But when you go back and look at, these legacy system of 30-40 years old, that is a very different level of complexity. So just only focus on that part. How do I take your entire legacy and move it forward slowly to be more AI compatible new system? Because that's otherwise it seems that will require a huge army of people, if at all. And most companies say, why bother? As long as it's working, let's just keep it running until it runs into ground.
And frankly, while we will be, migrating a lot of code over, a lot of code will remain because it doesn't need to change. Because as long as you can create a facade over it that allows it to operate with AI agents on top, perhaps the underlying code for a lot of this won't change for a very long time, 10, 20 years, right? But yes, there is going to be need for people who can kind of make sure that these existing systems work with other systems with some kind of a layer in between. And for some of them, yes, there will be a need to rewrite and remodel it in a new way.
A few months, I think about 5-6 months ago, Satya Nadella caused a stir by saying, SaaS is dead. And it got, I think, that, I think it's pretty much become as legendary as Mark Andreessen's Software is Eating the World, I think 10, 12 years ago. And since then, I think he also tried to explain that, okay, this is a different context, this is what he meant, and so on. But there is probably some truth to that. Like the way SaaS was done historically, and again, it's very relevant for India because we have had reasonable success in SaaS over the last 10, 12 years, is what SaaS means and what does it mean to be a SaaS startup or a company is going to change significantly.
Absolutely. I don't think it's dead at all. I think, in fact, I feel like there's a lot of opportunity in SaaS, but the current form of SaaS will need a huge transformation. So first of all the SaaS tools are in some sense, I have a database and then I'm doing some kind of workflow on top of the database. I'm abstracting very,
But maybe let's slow down. Why don't you also explain what exactly is a SaaS? What does it like very simple, let's say, I don't know, simple CRM software like Freshdesk or something else, Freshdesk is definitely not simple, by the core idea is maybe simple. So just explain what SaaS is and then we'll come back to, why it's going to change dramatically.
So perhaps it's useful to see what preceded SaaS, right? So before SaaS, people used to buy software and they used to run it in their own companies. And they would pay a one-time fee for buying the software and then they would run it. And the typical software would be something like a CRM, where I want to manage all the customers that I have. I want to manage all their details. What's their email address? How much do they have I paid? What is their billing? And so on, details like that. And I keep it in a database where you just think of it like a Google sheet, right? And that's basically what is known as the database. I kept a record of all of my customers. And on top of that, I had an interface, an application interface, which allowed me to update a customer or to see whether they are due for a renewal or those kinds of things. This is what software like Salesforce and so on do. Many people might be familiar when they're working at companies, they work with HR software as well, like Workday, where you can go and apply for a leave, or you can see what is my paycheck amount and get my Form 16 and so on, right? So these are all SaaS applications. The change that happened from the old legacy software to SaaS software about 15 years ago was that instead of taking this software and running it inside your own company by your IT folks, you access it over the internet, right? And along with that change that, you're using a browser to use it, the other change that happened was the change in billing model, which is that I'm not going to pay you a one-time fee with the maintenance fee. I'm going to charge you on a per user or a per employee accessing the software. So think of it like Gmail. Everybody uses Gmail, but if I was paying Google on a per user in my family, then it would be a certain amount, right? So that's how companies typically today use and pay for SaaS. I think two things are changing. Number one is that this whole per user model of billing, I think that is dying. Today you don't, the way OpenAI charges is on the number of tokens or the number of queries or the words in those queries that you are actually using, right? And that's on a usage model that if you use it more, you pay more. That is not the typical way that SaaS has been built, right? And with AI, that becomes important because somebody uses it heavily might be using a lot more AI and a lot more energy than somebody who barely uses ChatGPT, for example. The difference between a light user and a heavy user, the costs are significant. So which is why OpenAI and most AI companies do on a usage-based billing. So I think this is one aspect of SaaS that is fundamentally changing. The second thing that is, I think, even more fundamental is that the functionality of the SaaS itself is now questionable whether I should have a database and just a workflow around it. When you can just ask an agent or an AI to do things for you, why do I need to have a strict separation between my HR software and my CRM software and my other performance management software and so on? So in most enterprise companies today, you have a whole plethora of different SaaS applications, each of them doing one thing. And everybody who joins the company has to learn, okay, how do I apply for a leave? Where do I go for performance management? How do I update my CRM software? If I want to get analytics, then what do I use? And this huge number of SaaS applications is actually causing people to be inefficient. With an AI agent, I can actually just ask it, go fix my leave. And it will figure out what HR software it should update. So when that is changing, then the whole SaaS model itself is now changing because in no specific user actually used your software for HR.
Yeah.
It was the agent that used it. And in that case, how do I bill? How do I get value? How do I know whether this was what I should pay for? All of that is going to change.
And does this mean there is an opportunity to build this AI native SaaS or whatever is going to be called in future agentic software from scratch? Or a lot of it means the current players will somehow just end up embedding AI in their existing workflows?
Yeah, that's always the traditional tension between whether the incumbents can innovate and be disruptive enough and be forward-thinking enough, fast enough, right? I suspect in this AI world, like in the mobile world, in B2C at least, many of the older players were caught napping, right? And the innovation happened fast enough that new players came on, right? And sometimes disruptions happen that fast. And that kind of catch you off guards that the incumbents can get disrupted. But in this world, I suspect that the incumbents are innovating and are very, very wary of this change and are investing huge gobs of money and so on. So I suspect the incumbents, or at least the big ones, will get bigger and the small ones will die.
What about one of the aspect of AI is we talked about natural language in a text context, but voice is also becoming very natural to converse with these AI agents. Does it also imply that overall user interface paradigms also need to change and evolve? Because we still think of the current paradigm is there's UI, which is linked to some database, and you do a bunch of stuff, information goes, API calls, information comes back, you display again on the screen in whichever SaaS or you're looking at. But with AI, do people need to reimagine the user interfaces completely?
Absolutely. Though my own point of view, it's not voice, right? In this initial world, chat and even voice is a sequential interface, right? I say something and then I get an answer, and then I say something and I get an answer, and which works very well for search and learning, research, those kinds of use cases. But if the web was like that, it would be a very sad place. Right? When I go to YouTube or Amazon or Myntra or so on, I'm getting in parallel, my eyes are getting a lot of parallel information. So the bandwidth is very high. And then I respond back with just, I can navigate it with my mouse and click this or that, right? So there's a lot of parallelism and high bandwidth communication interface that is happening with the web today. We have to design what that looks like for the AI world.
Yeah.
But it is probably not going to be, there will be a lot of chat, there will be a lot of voice, but I don't think that new interface has yet been designed.
So last few years, Meta has been promoting their Ray-Ban glasses. I don't know if you have tried or not. And recently, OpenAI acquired Johnny Ive's stealth company, and Johnny Ive of the iPhone, iPad fame, and probably one of the most legendary technical designer of our time. When you read something like this, what do you suspect? When OpenAI and Johnny Ive, what kind of things they will possibly try to build, which is very different compared to whatever we've seen?
Yeah, see, in the long term, I haven't used the Ray-Ban glasses yet, but I think that anything that can look at the visual world and do AI on the actual physical world is going to be huge, right? I don't think the problem of, language models, LLM themselves cannot actually do a very good job of the world, the physical world, right? They're good at text.
Yeah.
So being able to absorb the physical world and be able to do things on it, I think that is a huge area. So I do think glasses or some other form factor like that, which allows the world to know what my environment around is going to be big. Also, I think wearables, I have been always, we've tried so many things on wearables ourselves. I have been disappointed in what they can do, because at the end of the day, almost anything they can do, a mobile phone eventually ends up doing it better, right? So I think the actuating interface, the things in which we actually change things in the world, I'm not yet convinced that anything or even genre of things, that there's anything that is better than a mobile phone. So I suspect consuming information, glasses or something like that will win. Doing things in the world, I am not yet sure there's anything better than a mobile phone.
for the foreseeable future, but hopefully at some point something better
so
comes
hopefully.
along.
I suspect that actually the thing that I'm very, very bullish about is a humanoid robot, right? I think in the next 10 years, we're going to have that in our homes, right? And they'll be able to do amazing things.
Yeah.
But there's a lot of problems that we need to solve in order for that to be true.
And you think humanoid robots are that far out? If you look at Tesla with their Optimus robots, they keep announcing more development every year. They have more and more fancy demos. Seems like it's almost there. It should be able to walk out of the factory floor any day now.
Yeah. So the first Waymo car I saw in Mountain View was in 2013, 14. Yeah. And it's, I don't think it's still there in the Bay Area even, right? I think in San Francisco it's there, but it's been 12 years, right? And it's not like it's not making progress. That field is making amazing amount of progress each year. But some problems are just so damn hard, right? So I think the humanoid robot will make amazing progress, and every year we'll see good news that, now it can do laundry.
Yeah.
Now it can do this, that, or so on. But in order for it to cross that threshold of where many people, or at least, we actually see it in 1% of Indian homes or, even US homes, I think that is probably about 10 years away.
Yeah, I think the day humanoid robot can either do laundry or maybe in Indian context make roti in the kitchen. That way we know that is a GPT moment for humanoid robot. It can be able to do many other things. Just going back to enterprise. So today let's talk about the adoption in enterprise. Now last 2-3 years, there is so much hype and excitement, and these models are really getting better that we can see every few months they're significantly better. And now I think GPT-5 should come out. Again, there's a lot of expectations from that and so on from other models as well. But adoption in the enterprise still not, it's not like they're starting to rewire a lot of functions and doing things very differently. What's holding it back? When do we see some real change? And ultimately the change has to reflect the P&L needs to look different. Either you say growth rates are going better or the bottom line is improving. If both are constant and even if they reconfigure everything, have 100% AI, it doesn't mean much.
Yeah, absolutely. This has been the conundrum that, I think in the last 2 years, most of the industry has been noticing, right? That in the consumer space, the number of people using ChatGPT and the like has been really, really high. And it's not just that they are playing around with it. If it's like, I would say about 30-40% of total ChatGPT type users are also deriving huge amount of value from it, right? So that is true in the consumer space. In the enterprise space, it's very bipolar, right? So there are the typical consumer use cases, but morphed to the enterprise, like search. I need to search in the enterprise as well. So that is people, because they're using ChatGPT, they don't want the same, give me the 10 links that Google used to do. Now they want like answers, right?
Yeah.
So that is highly popular. Same thing, sometimes in ChatGPT, a few, not very large number, use it for research, right? Which is a different problem than just answers. That is also very popular in enterprises where compare our company's product against some other company's product and give me a go-to-market strategy. Right? This is a research problem, and it creates a good 500-page article for you, right? So that is also used. And then the third thing that is being highly adopted is programming, coding part of programming, right? These three use cases are highly adopted. But once you go beyond that, the adoption is very low today, right? Even in things that one would think that, are easier problem to solve. Like, for example, IT help desk. That's an area I work on, and the adoption has been very low so far. It's growing, but it's definitely not skyrocketing, right? And we can talk about the problems there. Same thing for customer support. Same thing for financial records and, finance, which one would think is a very structured problem. So the other areas have still a lot of catching up to do.
But what is holding it back? The technology readiness itself? There are issues around the edges, or more change management within organization, fear of unknown, some maybe hallucination issues?
Yeah, we should break it down. Each of those is a separate problem, right? So there's definitely an adoption problem and hesitation problem because people fear, rightly so, that it can give you hallucination and wrong answers and so on. But I think that is only 20% or 30% of the problem, right? There are many use cases where that would not be a problem. Like, for example, if I want to give you, my VPN is not working, and why? What are the possible reasons? Right? It's fine if it hallucinates a little bit. The benefits might completely outweigh the cost. But even there are problems, right? One big part of the problem is that companies' knowledge bases are not as well informed and there as one would think. Like, even if you take customer support, the way customer support in most companies works is that you bring in somebody from college and then you spend a month to 3 months just training that person.
Yeah.
If I asked any supervisor or agent to go train this AI, there's no reward for me, right? There's no motivation, there's no process, there is no way in which you actually, even the AI system itself is not attuned to having a guide teach them, right? So this learning problem is much harder in the enterprise than one would think, because the information and processes are not there. And the third reason is that is a fundamental AI needs to itself get better, in the sense that we have built AI assuming that all knowledge is global. The language model thinks that all knowledge is uniform and that everything can go in and it helps improve the AI. But in a company, that's not how companies operate. There are silos of knowledge which are siloed for good reason, right? And how does it know that, okay, this piece of information can only be known by this party, this piece of information can only be known by this guy? Like, for example, if it's a legal document, that can only be known by the legal department. There's an acquisition going on that can only be known by these people, right? And if I want to ask a query, then how do I interface between these things to get the right answer to you? That's an unsolved problem today.
So that will require some kind of significant architectural adjustment to be able to create those compartmentalization within the entire, all the weights and parameters of the.
Exactly. So there's two possible ways to solve it. One of them is that you create many LLMs. So this would take what exists in the human world and replicate it. It isn't that there's one shared knowledge, right? The CEO of the company, right?
Yeah.
It is that there is a legal expert, there's so on, and they have strict interfaces on what they're allowed to share between each other. That is one multi-agent solution. The other possible answer is that there is one God LLM for the company, but it knows how to break apart the information and expose the right things to the right people. That is embedding the permissioning and the org structure into the LLM itself. It's not clear what is the right approach yet.
When you hear things like we'll very soon be able to see a single person unicorn, $1 billion valuation company. Recently, I think Base 44, less than 10%, I think company got acquired for $80 million. So on. You think, with everything we're talking about AI and how the technology is improving, those things will be increasingly possible, that a small number of people are able to run fairly large operations at scale?
Absolutely. In 2016, I wrote a Medium article called The Autopilot Company, right? And I think there'll be many kinds of business, like dropship, right? Today, you find like college kids actually running a dropship company out of their dorms and reaching 10 million-ish rate of revenue already. Because dropship is actually, while it's a complex operational problem, a lot of the steps are digitized, right? So it's very easy, actually, I think, to create a dropship company which can be run by one human already today without AI, right? So with AI, can that 10 million become 100 million? Absolutely, right? So, and it's not just dropship. I think there's many areas now, like create a little AI tool, a to-do list. One of the things we haven't talked about is personalized apps. Like niche apps are easier to build today than before. So many of these things can also become much bigger and possible today than before.
You should share that article. Incidentally, at Nurex, we have defined our long-term vision as autopilot enterprise.
Yes.
And that's what I see. I think based on everything I can see right now, the large number of processes inside the company can and will be automated. And things will just like your autopilot car, or self-driving cars, a lot of things should just run on its own. So I think some version of that feature will play out. But let's also talk about the evolution of LLM itself. So for last few years, all the excitement is coming from the so-called scaling laws. You keep feeding more and more data, and suddenly all these emergent properties keep emerging. What is the role of AI research in the coming years? You think there's still a lot of fundamental breakthroughs need to be made, which are very research, IP oriented, or at this point it's just engineering, just keep feeding more and more data as well as optimization, just very high quality engineering, and LLMs will keep giving us more and more.
Yeah. There's a lot of debate in the AI world about this. I have my own point of view, and this is not as well informed as some of the experts, obviously, that work in this area. But my own, just as a user of these LLMs, my observation has been that we've reached a diminishing returns kind of thing from data, right? Because data has been exhausted, right? So we're kind of hitting the limits of what we can do with more and more data. I do think that there is still some fundamental things that need to be solved in existing LLMs for permissioning and data, right? We are today with this assumption that we have this global mind and that all knowledge is everyone's knowledge, and you feed that into LLM, it becomes more powerful. How you work with like different people having different pieces of information, that problem is not solved. We talked about whether you should solve it with lots of mini LLMs working together or one big LLM that has partitions of data. That's an unsolved problem. But I think a much bigger problem that LLM itself may not be the right thing to do is about what Jan LeCun also calls the world model, right? We don't understand. Language is great for certain sets of things, right? But even animals without language do a lot of reasoning in the world, right? So there's a lot of problems in the world that cannot be solved with language models. Like for humanoid robots, I think we need a whole other thing than not an LLM, beyond an LLM, right? Those set of problems have not been solved. And then there is yet another thing for structured data. Like when we teach a kid math, one way to teach it is just give them math problems, and then they kind of get the pattern and abstraction. But then if you have a really good teacher, they kind of teach you the concepts. So, for example, in a business, there are certain orgs and what org structure works better, what are the business models that will work in this domain. It's very hard to learn it just from data, right? And there is some conceptual understanding of what are the right abstractions, what are the interface between different things. These things are not very well represented inside an LLM today.
And where is the center of gravity for all this research? Is it mostly inside places like OpenAI, Google, Meta, Anthropic, or academia has a role to play? So?
I think academia also has a role to play. Unfortunately, though, right now that the capex needed in order for you to get to the frontier of what an LLM can do and thereby extend it in these different ways, it just requires so much investment that it is currently most of the interesting work is happening in those 5-6 companies you named. But some of the theory of new fundamental ways of doing which is beyond an LLM, that can be coming from academia.
And these, there are literally 4 or 5 names. I think whenever we say LLM, we basically mean either models from Google or OpenAI, right? And or Claude from Anthropic or Llama. I mean, DeepSeek maybe, but not much news for the last 4 or 5 months. And I think there are question marks also whether DeepSeek can significantly better. It was, kind of one breakthrough or not. But irrespective, I'm sure you will agree that nearly everything that we do will have some component of AI in it, which means it is calling some inference engine, which is provided by these 3-4 companies. Is that also a huge challenge for the world, and in particular for India, that anything intelligent device or intelligent software or intelligence in the company need inference provided by these 4 companies?
It is a huge challenge. I suspect that we should not get disappointed and give up because of that, right? Because I think there are other problems that we can solve which will become the centerpiece of the problem in 5 years from now, right? So I don't think we can compete in the LLM world per se. But assuming LLMs exist, I think in the long run, the delta between a mini LLM that you can run on your computer of 10 years from now and the best LLMs will start to diminish. The delta will be relatively it'll be big, but not that big, right? And I suspect that a lot of value can be created by taking what you can run on your own mini LLMs, even on your mobile phone, and solving problems for India, right? There is so many problems that now become feasible for which the TAM was not big enough before. And now the Indian smaller TAM is still big enough because the cost and the investment needed to build it is so much lower.
And these smaller models are what? They are more built on open source models or kind of custom built for a specific context?
You can actually take like Llama and run it on your Mac Mini today, right? And in fact, I do, right? Yeah. And you can build little apps that run locally on your thing with no problems. Yeah. In fact, it's often a little bit of a surprise the first time you run it that you just download this, 120, 150 gigs worth of, a model into your machine, and you can ask it pretty much any question of the web. Like, what's the capital of Paris? Who was the president before Mitterrand, right? And that thing is answering it. So basically, I've taken the world's knowledge and put it into my phone or my Mac Mini, right? It's amazing.
How technical do you need to be? Let's say somebody who has never done programming in his or her life, listening to this, wants to download this Llama 7 billion parameter model, run in their Mac Mini. What kind of instruction do they need to be able to do this?
It's very little because it's all there on the website, right? You just need to download it. The interfaces on top of that are not great. I mean, they are command line interfaces today. But if you pair that up with a Replit or, a cursor and so on, you can build a little application on your own that runs on your mobile phone or your Mac Mini, right? And it can be something that's very, very specific to you, right? So if I want to manage my to-dos in a certain way, it's very easy for me to build my own to-do app, list app, right? Or if I want to kind of keep track of all my expenses, right? And I do it in a certain way, very easy to do that.
Everything, Shamik, you are seeing in the AI world the last few years, is it making you optimistic about next 5 to 10 years, pessimistic about, or I have no idea what's going to happen?
It makes me very optimistic for what consumers will face, right? So when I look at my world from a consumer perspective, I look at, wow, hopefully within my lifetime, I will have a humanoid robot. I will have, my laundry will not be a problem anymore, right? All of these things will become good, right? And I am very optimistic about that. I feel a little sad about how much time and effort I've spent in learning computer science, right? Because I think a lot of that, but this is not just with AI. Throughout my career, like everything has gotten outdated because things change so much. But I feel like a lot of I wished I was young at this age, right? Because then there's so much to invent.
Yeah, I think we are roughly similar age. I would like to believe I am young at this age. So I'll encourage you to feel the same. There's so much that happened also in general in the longevity space, and maybe AI will help us unlock even more, But I mean, just maybe going on a tangent for a second, but I think, if somebody in the, let's say, 50, early 50s, you have almost entire career ahead of you. Otherwise, what will you do in your 60s, 70s? I don't know if your plan is to retire or, do something, but I feel like, because I don't want to retire, which means I have to really think about what I do for next 30 years.
Yeah, no, I think everything is one of the good things is that, previously learning programming or learning a new skill used to take 5 years, right? Or to become really good at it. Now you can become good at something in much faster because the learning resources and even AI makes you much more powerful. So, for example, I've been trying to learn about quantum mechanics, right? It's like a very, very difficult thing to learn, right? Because it kind of throws you off every time. But like within a week now, I think I've kind of got like the basics of it, right? And it would have taken me at least a month, 2 months to get to the same point now, right? Because I can very easily say, okay, create a diagram that shows this, right? Okay, shows me, tell me what, one of the X gates does, right? And so on. It kind of creates the images and creates the visuals for me to learn that. So
GPT is your go-to tutor for this?
Yeah, I use GPT with voice on my walks to say, okay, now what, tell me about this. No, I didn't get that. Explain it to me again. Create a diagram for me to do that shows this and so on.
So leveraging your quantum mechanics learning experience, why don't you give like mini tutorial? Somebody, everyone has some learning desires in life. Someone who want to learn about yoga, or I don't know, playing keyboard, or about tracks, or how can somebody leverage GPT? Like what is a good way to organize a learning experience so you really make steady progress over a period of time and feel like, maybe I feel as good as I have done a course, or I work with a personal tutor, or just really made a progress on my own, which I wouldn't have been able to do in the past.
Yeah. So first I'll fork, right? There's two use cases I have. One of them is if I'm preparing for something that has a deliverable. Like, for example, if there's an exam or I have to create a document.
You still take exams, Shamik?
No, but my daughter does. So sometimes I'm helping her, right? So there's a different flow that I use for that, right? Or if I have to create a PRD for some new topic or a strategy doc, then there's a certain deliverable, right? And there's a different process for it. It's much more structured. But if I'm just learning about something like, for example, quantum mechanics, then the flow that I use is that I take 2 or 3 books on it, and that I can get the PDF of, right? And I put that into ChatGPT, right? And in some sense, this is what is now known as context engineering, which is kind of the next level of prompt engineering. So you're constraining the context of ChatGPT to something, right? And you get much better answers that way. Then you say, okay, now you have this context. Typically, it'll be a good book that somebody has said that this is the right one to study quantum mechanics, for example. And then I go on a walk, and when I walk, I'll start asking, so explain to me, what is the chapter 1, right? What is it about, right? And then I will have a discussion like, okay, these are the concepts that are there, that this is a qubit. A qubit has these things. And then I will ask all kinds of questions to it until I feel I understand that concept. And sometimes, spoken language is not enough. I need to see a diagram. So I'll say, create a diagram that explains how these concepts are related, right? And it will generate an image. Yeah. And then I will look at the image, and I don't get it, and then I'll ask some more questions, right? So this is phase 1. And then phase 2 is that I will try to do something with it, right? So I will try to, because you first listen and learn, then you actually, when you do something, then you try to, then you actually face the problems, right? So, for example, in quantum physics, to creating a circuit is actually a very hard problem, right? Even if just a 3-gate circuit is extremely hard, right? Just trying to reason with it because the number of possibilities is so much. So I'll try to take a problem, say, give me the simplest problem right? And then it'll tell me a problem, and then I'll try to solve it. This is how I would do it. And then it'll tell me, no, this is what you got wrong, right? And then I'll try to teach it to somebody, right? And, typically I'll try to find somebody else and I'm explaining it to a friend or so on.
It was excellent. I think GPT and other LLMs are outstanding learning tool, if nothing else. And I think anyone with some interest in learning can really start using, and as you are articulating, people can really modulate up and down. You can zoom out to 100,000 feet level. Why does quantum mechanics matter? To all the way to very granular, okay, let's solve this one simple toy problem together step by step. And in my learning with GPT, sometimes I just express my frustration that I'm really not getting it. Can you try alternate approach? And it does, sometimes it does. Human teacher, you will be little, you may not be able to speak your mind freely.
But also as just a product person, as I'm sure you also see this, right? I often get frustrated in the things that the ChatGPT is not able to do, right? And for example, empathy, adding the right sense of humor, and how interjections work, right? These are 3 areas that I think are like unnatural in all these LLMs and AI today.
It's just on a closing note, do you think, most of our conversation today was mostly about either this text response, voice response, or code generation, and you mentioned a little bit of image generation, but full-fledged realistic video generation like what Google's VO3 recently demonstrated, how long will it take for us to, let's say, people to completely regenerate this podcast? Let's say a year from now we want to reshoot, but you are not available, and I want to recreate this thing. We'll get then 1 year, 2 year where, all the context of Shamik and all the context of Mukesh, and having a realistic conversation like this.
Creating a conversation will be relatively solvable. Creating a a thing that you want it structured in the right way, that with constraints, saying it has to be about this topic and this is what I want it to be, getting it right, right? That I think is 5 years plus away, I think. But I think it's still solvable. But the general video problem is a lot bigger than that, right? And I don't think we've invented the LLM equivalent of that, right? That could be anywhere from 5 years to 20 years away because we just haven't invented the core thing.
Got it. So it requires more fundamental architectural breakthroughs or maybe perhaps new paradigms.
Right. Like, see, for example, video generation, right? We are having a conversation. If you give the script and you put two dummies here and two green people wearing green, right? Replacing it with you, replacing it with me, and your dummy being able to say the script and me saying the script is actually quite solvable today, right? With a little bit of work, within a year or two, we can get that, right? But that's a very, very constrained version of the overall problem.
Right. It's not an open-ended, free-flowing conversation.
Yeah, I mean, in order for it to be really that, what you're saying, first of all, we have to have something that has all the context that a Mukesh has. And it has to work against somebody that does not have the context that Mukesh has, but has the context that Shamik has, right?
Okay, maybe if we eliminate the video part, is somewhat related to what you're saying, just collaboration in the organization. Correct. Because a lot of humans bring all of there is now large set of people with all kind of mutual context.
Exactly.
Which plays a role in.
And the whole LLM model today is assuming general context. Perhaps if you can send 2 minutes, there's a fascinating video I saw, I forget where, in BBC or so on, about a 3-year-old versus a 5-year-old child, right? If you take a 3-year-old and you tell them that here's this ball and I'm hiding it behind that bookshelf there, right? And I'm going to get John, who has not been in this room, and I'm going to ask him, where is this ball? Where do you think he's going to say? Right? The 3-year-old will say, there. Because the 3-year-old thinks that knowledge is global. If I know something, the whole world knows something. The sense of identity, and therefore what I know is different from what somebody else knows, is not there yet. Right? And between the ages of 3 and 5, you develop the sense of identity, and therefore that my mind is different from your mind. This concept of theory of mind is not yet built into LLMs today. And it's a hard problem to solve, right? And this is more evident in the enterprises than in the consumer space, because in the consumer space, most ChatGPT interaction, you're not collaborating with anybody else, right? But in the enterprise space, it's all about collaboration, and therefore this problem becomes a hard problem. But it also has reflection in the consumer space, because without this knowledge that I don't know what you know, relates to empathy as well. So hence the LLMs, because they say, hey, you don't know this, Mukesh, but I'm going to help you get there. This concept of empathy is also not there.
God, it's for me to understand, let's say, when I talk to you, I both assume and infer, and from prior context, that something about you, and when I'm interacting with you is going to be very different. Let's say I'm talking to, Delphi from my team here. I will interact with her very differently.
Exactly.
Like, while my overall global context is same, but LLMs, they almost talk to everyone as if they are the identical people.
Right, exactly, right. So not only do you need to have a model of what you know, you also have a model already in your head of what everybody else around you knows.
And what I know in context of that person.
Exactly, right? All of that is not modeled in LLMs today. Right? So that itself is, as we were talking of research, like this whole concept of what you know and what you don't know is not yet there.
Exciting. I think it's if compared to where we were 3 years ago, I don't think any of us are expecting to be at this stage. With so much so much excitement and so much almost like building dependency around LLMs. A lot of unsolved problems, but looks like the entire global might of intellectual talent capital, which is now adding up to trillions of dollars, is going to produce something very, very remarkable, and probably something that, is very hard to even imagine what that's going to be.
It's a great intersection of both the opportunity and the possible things that can happen, and the fact that actually capital is flowing to solve that problem, right? It reminds, of before our time, but in the 1960s space, right? When the opportunity of being able to go to the moon was there, and also the investment came in, right? So a lot of excitement was there. So I think similar things.
At least in the space, we can say, because of early investment in ISRO and so on, India's kind of caught up. It has a lot of capabilities and globally competitive. I think somehow we also need to find our groove for AI and LLM, because right now, there is a danger of being somewhat left behind in this, exciting, smoothing one.
I'm not so pessimistic because I think that we are narrowly looking at the LLM problem, right? AI services, multi-LLM collaboration, AI used for, India 2 kind of problems. There's so much to be done in AI that I think we're not going to be lost for opportunity.
Okay, that's excellent. There's something to be optimistic about. Shamik, thanks for taking the time. I think it's always fun to talk to you. And
Absolutely.
we'll keep looking for, what all the interesting ways you are participating and contributing to the development of AI.
Sure.
At SparX, we aim to bring to you stories of exponential impact. We share in-depth analysis of what goes behind success stories. If you find our conversations interesting, you can join us by subscribing to our YouTube channel. You can also listen to SparX on Spotify, Apple Podcast, or any other audio platform of your choice. If you have any suggestions on who we should invite or what topics we need to cover, just let us know in the comments. We are always listening, looking for ways to improve, and keep getting better as we go along.